We've all done it. You step outside on a clear, crisp night, look up, and see a sky scattered with thousands of softly twinkling stars. It's one of the most peaceful, universally shared experiences we have. But that gentle flickering is a complete illusion. The stars are not behaving the way they appear to be. In reality, a star is a massive, violent nuclear furnace. It doesn't pulse or flicker, it blasts a constant, unwavering stream of intense light in all directions. There is a second layer to this illusion. The star you are looking at is not actually in the exact spot it appears to occupy in the sky. So how does a massive, unyielding beam of light from a fixed point in space become a tiny, dancing dot by the time it reaches your eyes? To trace the mechanics of this, we have to track a single beam of ancient starlight from its source. Out in the vacuum of deep space, there is absolutely nothing in the way. For millions of years, this light travels undisturbed in a perfectly straight line. But that peaceful journey ends the exact microsecond the light collides with the outer edge of Earth's atmosphere. This protective bubble around our planet isn't empty space. It is a dense, turbulent physical obstacle course that the light must now survive to reach the ground. Earth's atmosphere acts as an unseen barrier, forcibly warping the raw reality of the cosmos right before we can perceive it. Zooming down into that air, we find a completely uneven, chaotic environment. The atmosphere is vertically stacked with varying levels of density. It's packed with constantly shifting layers of heat, dust, and microscopic particles. Think about sitting near a campfire. Intense heat creates low-density air pockets, visually blurring the space directly above. Conversely, imagine a large truck driving down a dirt road. It kicks up thick clouds of dirt and particles, creating dense pockets of air that obscure your vision. Our sky combines both of these extremes. Rather than a perfectly clear window, we are staring out through a massive, flawed, and constantly boiling optical lens suspended above our heads. When light crosses from empty space into a denser environment, it sharply bends. This is atmospheric refraction. As pockets of hot and dusty air shift, the light beam zigzags erratically downward. This constant scattering causes the star's apparent position to rapidly microshift. As this beam physically jumps around, the volume of light managing to hit your retina wildly fluctuates. It looks incredibly bright 1 millisecond and dim the next. That rapid, continuous cycle of micro-shifting positions and fluctuating brightness is the exact mechanical definition of a twinkle. Let's take all of that back down to the ground and look up at the night sky one more time. The flickering you see is not a property of the cosmos. It is the visual struggle of ancient light surviving our planet's turbulent air. The night sky reveals a hidden interaction between the deep cosmos and our own planet. These dancing points of light map out the invisible, swirling ocean of Earth's atmosphere, illuminated by stars millions of light years away. The twinkling night sky acts as a mirror, reflecting the chaotic, invisible blanket of air that keeps us alive.